Alright, here in our next problems, these look slightly different than what we've been doing in this section. Here we have 3p squared minus 12p equals 0. Now remember, in order to be able to solve these, we have to use that zero product property. But we don't have two things multiplied together here to equal 0. Instead, we have two terms. Well, is there any way that we could use what we've been working on to try and change this into a set of factors? Well, absolutely. We've been working on factoring, so we can do this. The first rule of factoring is always to pull out the greatest common factor. So in this case, our greatest common factor would be 3p. So when we pull that out, we're left with p minus 4 and then equals 0. Now we do have two things multiplied together set equal to 0, so we can use our zero product property. Either the first factor, which is 3p, could equal 0, or the second factor, the p minus 4, could equal 0. And now we can solve each mini equation. So if I divide both sides by 3 here, we get p equals 0 for our first solution. And for the second solution, if we add 4 to both sides, we'd get p equals positive 4. Now, just like in the one that we did before, we could actually go through and we could check these. If I check the 0, then let me put that 0 back in place of p. So it would be 3 times 0 squared minus 12 times 0 should equal 0. Let's see, 3 times 0 squared is 0, times 3 is 0, minus 12 times 0 is 0. So does 0 minus 0 equal 0? Yes, it does. And if we check the 4, we would also see that that works. If I did 3 times 4 squared minus 12 times 4, that should equal 0. Well, let's see, 4 squared would be 16, so that means we'd have 3 times 16 minus 12 times 4 would be 48 equals 0. 3 times 16 is 48. So is 48 minus 48 0? Yes, it is. So we can still go back and check these, even though we had to do some factoring first. All right, let's try another one. Here we have m squared plus 2m minus 15 equals 0. And again, we do not have factors equal to 0, but we can factor this trinomial. There are no GCF, there's nothing in common that we can factor out first. This is a trinomial, and it has a 1 coefficient, which tells us that we should factor by trial and error. So when we factor this, m times m is m squared. And now we have to think of factors of 15 that will somehow give us a 2. So I'm thinking probably 5 and 3. And the way they'll give us a positive 2 is if we do a positive 5 minus 3 would give us a positive 2. Now we do have two things multiplied together equals 0. So we could take each one of those factors and separate them apart. Either m plus 5 would have to be 0, or m minus 3 would have to be 0. So if I subtract 5 from both sides, we get m equals negative 5 for one solution. And if we add 3 to both sides, we get m equals 3 for our second solution. And again, you could plug the negative 5 back in and make sure that it works, and it does. And you could also check the 3 to make sure that it works, and it actually does.